So welcome everyone. My name is Chris Adams. I'm a senior applications engineer here at Formlabs. My day-to-day sort of revolves around finding new ways to use our printers and helping customers figure out how best to implement it into their workflow and see how that affects the way that they make things. We're super excited about today's webinar. We have Ryan and Mark here with us. They've both been using Formlabs printers and they're doing some incredible work. I'll hand it over to them to introduce themselves.
Hi, my name is Mark Honschke. I'm the RP lead here at Microsoft. I manage all of the RP resources for our hardware development for Surface, Xbox, Quantum, and all of the above.
And my name is Ryan Laprise. I'm a design engineer here at Microsoft. I kind of help delegate the making of all our prototypes and models, whether it's through design or engineering. I work with all the groups, same as what Mark just said.
Awesome. Thank you guys so much for joining today. We've got a whole bunch of topics that we're going to dive into. Super excited to share that with everyone. While we're doing that, we do have the chat live. So if you have any comments or want to say anything to fellow attendees, you can do that throughout the entire webinar. We're also going to try and answer any questions that we can get to at the end. So there's a Q&A button on the bottom there. You can post anything in there. It could be on materials or anything on our side, or looking for a little bit more detail on any of the topics that Ryan and Mark are going to cover with us today. So anything you want to know or anything you want to share, post in either of those two locations. I believe we also have a start poll. Just helps us know who's using our printers, how they're being used, and make sure that we're making webinars on topics that are interesting to you guys. So it's just two quick questions. It should be popping up on your screen right now. If you could click those real quick, and then we'll get right into it. Perfect. Thank you, everyone. I see those answers coming in. And we've got attendees from all over: Germany, Switzerland, Bavaria, Venezuela. Quite a wide range. Glad that everyone was able to make it today. Perfect. All right. And if you just joined, there is an entrance poll up. If you could click those super quick, it'd be appreciated. Okay, we'll leave those up for another 30 seconds or so, but let's get started. So again, thank you guys for joining. We've got a list of some interesting things that we're going to get into. But to start it off, I'd love to discuss a little bit about the sort of Advanced Prototyping Center, what that is, how it came about, and how you guys fit into that at Microsoft.
Yeah, so the Advanced Prototyping Center was a model shop that was created initially for Microsoft hardware a long time ago, when Microsoft was only into peripherals, mice, keyboards, stuff like that. The whole reason Microsoft got into hardware initially was to advanced Windows features. So you want to add the Windows button onto hardware and all the PCs out, in the world, and so you want to make sure that your vendor or your vendors are adding that feature to their computers also. And so Microsoft would create keyboards and mice to advance those features and drag along the vendors to make sure that they were adding those features into their hardware also. Fast forward a little bit, and Microsoft decided that they at one point in time, the PC market was a race to the bottom, and to see how cheap you can make a PC. And the issue was that nobody had ever experienced Windows on a premium device, a device that was designed specifically for Windows in the way that Windows the software is designed, which is what birthed Surface. And so we initially started out as a very small model shop, and then once hardware became a pillar of Microsoft's business, we've expanded greatly. When I initially started, we had 3D printers. We have since grown into a fleet of 27 printers spanning across multiple technologies, along with CNC and waterjet and all the other fun tools that makers get to play with.
Kind of sounds like a dream environment. You've got basically every tool that you need to make whatever you want.
Oh yeah, definitely.
Yeah. And you said that it started just with primarily the Surface as a big hardware undertaking. Is that still what you primarily focus on? Has it expanded to other areas?
Yeah. So like I said before, peripherals and keyboards initially is what we supported, and then Surface came along. We also support Xbox, quantum computing, HoloLens, and our AR VR endeavors. Pretty much, if it's hardware at Microsoft, the APC, the Advanced Prototyping Center, supports it.
Very cool. Do you have a favorite within there, all of the different areas that you support that you find the most interesting to work on?
Well, as a consummate video game player, yeah, I love working in the Xbox arena, but we like Surface also.
That's fair. My girlfriend has the Surface. I have the Xbox, so I think I have the same favorite as you. And what does the scope of the work look like at the APC, the Advanced Prototyping Center? How do you decide what to work on or what not to work on, and what does that look like in your line of work?
Yeah, the scope of work for the Advanced Prototyping Center covers hardware development from start to finish, from the initial design, the initial idea and design of the first prototypes, all the way through production. We've actually created, using 3D printing, created fixtures for production where we're working with the production engineers to solve an issue that they're having on the line, and we prototype that here and then send that over to our factories.
Okay, so it's not just in the initial product development. You're doing prototyping, and I think a lot of time when you say prototyping, your mind goes to prototyping the product, but you're prototyping beyond the product. You're prototyping tooling and things like that that are going to be implemented in the manufacturing line.
Yep. Yes, definitely. So 3D printing wise, we tend to help with, when it comes to beyond the initial hardware development, we're creating prototypes of the products themselves. We are creating fixtures for our reliability labs, where literally we're creating robots that press buttons thousands of times. Where our CNC department is creating the tool pathing for all of the milling work that gets done for our end product, the actual stuff that takes place in the factory. So we'll prototype that tool pathing here in Redmond, and then that typically gets transferred over to the factory. So we'll find the most efficient way to create a product, and then partner with a factory to turn that into an end product that gets delivered to a customer.
That's very cool. I like how you use prototyping beyond what is just sort of the initial realm that most people think of in prototyping. Maybe you're gonna print a mouse to see how it feels and then go to injection molding, but using it as a prototyping tool through the entire manufacturing process, I think is something pretty innovative, pretty unique. So while you're doing this through the hardware development, using 3D printing, using CNC milling, how do you decide where you're going to use a water jet for one tool, or where you're going to use 3D printing or a specific type of 3D printing? How do you make those decisions?
So really what it comes down to is the right tool for the right project. 3D printing is usually the first step in the prototyping, and then from 3D printing we can move on to CNC or whatever tool makes the most sense for the process.
Okay, that makes sense. Yeah. So then sort of diving into the 3D printing side of things, because that's what we do here at Formlabs. I saw from the entrance poll that most of the people tuning in today are familiar with 3D printing as well as with Formlabs. If you are unfamiliar, we make engineering grade small format 3D printers using SLA technology, or masked SLA technology. We do also have a powder bed line called the Fuse 1 Plus, but we're focusing primarily on SLA today. And we didn't have it in the poll, but I'm quite confident that 100% of the attendees are familiar with Microsoft and Microsoft's products. So focusing on the Form 4, how does that fit in at the Advanced Prototyping Center? What sort of materials are you using? What does that look like over time? How'd you get started using Formlabs technology?
Formlabs technology was championed by Ryan. Initially, we were heavy in other technologies, and we brought it in as a tool for our architects to be able to print parts outside of our normal process. So typically what happens is we accept requests all day long, and at 4:30 we shut off accepting requests, and then we process that data, kick off all the prints overnight, and then deliver parts the next day. It's a great process for delivering a lot of parts in a very short period of time. The only snag we hit is if somebody needs something really quickly. I have an idea and I just need to get a part so I can print it and move on to that next step. Our system isn't really set up to be able to respond as quickly on with those off the cuff ideas. And so to be able to handle those things, where a model maker may have a quick idea and just needs to kick something off, we brought in the Formlabs technology, initially starting out with a fleet of Form 3s and Form 3Ls, and now upgrading to the Form 4s, which have vastly improved that idea to part time frame, shortened it quite a bit.
Yeah, the switch from the 3 to 4 has, I know we put it as a quote, and anytime you see a quote on a business's website, there's probably some amount of skepticism, but the whole like changing the way you work, and it very much has. The Form 3, while a great machine, just doesn't quite have that same level of speed. And if I was working on a project and I have something to print, it's probably going to be a 5 or 6 hour job, and maybe I'm looking at it at 10 or 11 in the morning and thinking, well, it's not going to be done before I leave the office today. So I'm just gonna, do what you do and put it in at 4:30, and I'll take care of it the next morning. And so a year ago, working on the Form 3, that was sort of how I handled all of my projects. But now the Form 4 is so quick. If I get something at 10 or 11, I'm thinking I need to start this before lunch, so that way it's done afterwards. And yeah, I think I'm now the bottleneck. Before, I was waiting it to the end of the day, and I can move a little bit faster than the machine. And I'm sure there's people out there that are probably still fast in the Form 4, but I'm certainly not. It's changed the way that I've worked.
I think before, with the Form 3s, the average print time was like 6 to 8 hours, and so it was like by the time you finish designing a part midway through the day, like you're already like by the time it's going to finish, it's going to be like 8 o'clock at night, and you have to wait till the next morning anyway. Uh, so the Form 4s, I think when we were testing it out, we were struggling to get prints longer than 2 or 3 hours, and that's been a huge game changer for us for sure.
Yeah, yeah, it's it changes the way that we make things, that's for sure. And Ryan, you were kind of the spark that started the Formlabs Microsoft journey with the APC. I'd love to know a little bit more about how you were already familiar with Formlabs and what that was like from your side, introducing
Yeah.
that technology to the center at Microsoft.
Yeah, so I came from the East Coast, from Massachusetts as well, from a place, prototyping and design agency called Empire Group. And I think we helped, we made a prototype of the Form 2, like the orange shield at one point. And then I forget how we got into it, but we had a Form 2 for a good portion while I was there. And that's how I kind of knew about Formlabs to begin with. And then when I moved to Seattle to Microsoft, we had the majority of our prints were PolyJet. I think we had a carbon printer at that time, but that was still kind of iffy. Like support generation was kind of an issue with that, and it was just a tedious process to get SLA parts as well as like the build platform being small. And so it was kind of interesting. Like my Empire Group had a large format SLA printer. So I was used to that quality of prints. Like we couldn't do color, but I was used to the surface resolution and the strength of SLA to begin with. And so coming to Microsoft, that was a bit of a shock going to like the more fragile PolyJet parts. And so that was my inclination to get Formlabs, was to just get better surface quality and better uh, material properties.
Mhm.
And so the
Very
Form
cool.
3 came out, and it seemed to solve a lot of the issues that I had with the Form 2. And so I got very excited about it, and yeah, pitched it to my colleagues. And yeah, we ended up getting, I think, was it 1 or 2 to begin with, Mark?
Yeah, something like that. Yeah.
Yeah, and then
It's hard to keep track. Our
yeah,
fleet continuously is so continuously changing. SLA, before Ryan came, SLA had a really bad name here in the APC. So APC, when it started, its foray into 3D printing actually was with purchased a 3D Systems SLA 5000, I believe it was. And by the time we moved over to PolyJet, 3D Systems was a 4-letter word, along with SLA in general. And in fact, SLA was considered old technology that we had moved on from. We were no longer going to be utilizing any of that because we're heavily invested in PolyJet, and that's the wave of the future. And so we hadn't even considered SLA until Ryan made a pitch for it, and the two factors were in Formlabs' favor. We had a champion in Ryan telling us, this is technology we definitely have to have, and the barrier to entry was really low. Whereas in traditional SLA, you were talking, thousands, if not hundreds of thousands of dollars to just get started. But as soon as we brought the Form 3s in-house, and we were, like I said, we had initially brought them in specifically as an internal tool that was only for our model makers and architects to use, but quickly realized that with the breadth of material properties that were available with Formlabs, that we quickly started branching that out to our wider audience and supplying those parts to our partners internally.
Very cool. Yeah, I didn't realize, Ryan, that you had worked for a lab that helped prototype the Form 2. That's sort of a full circle of you helped us prototype the Form 2, and then now we
Yep.
help you prototype at Microsoft with, probably at some point the printer that you helped us um, design here. Um, Sort of looking back on the Form 2 and your experience with it, you know, better part of a decade ago up to now using the Form 4 and all of the other technology with the growth that the APC has had. What have you guys seen as sort of the most impactful change with the technology over the last several years? And where do you think is the next big steps, or the pros and cons of where we're currently at with the technology?
Um, so I'm having trouble remembering what improvement. I've used the Form 3 a lot longer than I did the Form 2 at this point now.
Mhm.
So I forget what issues I had with the Form 2, to be honest. But between the Form 3 and Form 4, I'd say my favorite thing is the cartridges not misregistering or not registering, um, and just the speed and the surface finish is just crazy. And less moving parts means less stuff can go wrong. I think we had a couple printers where the resin tanks would leak onto like the rollers of the light unit,
Mhm.
and that kind of caused some issues. And so going to a much more simple architecture, and just like it's way easy. The Form 3 was easy to change out materials, and the Form 4 somehow makes it even more easy, uh, which is crazy. But
Yeah,
yeah, overall, I'd say it's been a huge improvement between the 3 and 4, which is pretty awesome.
glad that it's a good experience. And yeah, less moving parts is always a good thing. Sort of like the engineering expression of the best part is no part. Um,
Mhm.
Right.
Mark, you touched on it as well, the material library and sort of switching over from previous technologies that may have had some other advantages like multiple color and things like that, but the material properties and the range um, of those properties that the Form 4 has to offer, and you guys use multiple different materials. Um, is that something that you service on the APC side, sort of um, providing information on the different materials? Is that something that the designers and the engineers will reach out to you with a specific material? How do you go about choosing what material to prototype in?
Yeah, once again goes back to, right tool for the right part. A big part of my job is understanding the material properties of all of the processes that we run, and ensuring that we're sending the request in the right direction to get the the engineer the right part in the end. With Formlabs, the fact that there's a wide breadth of material properties is amazing. We use it from everything from end use parts to um, uh, metal forming molds. We've even cast metal MIM metal parts in molds off of Formlabs machines, all the way down to um, uh, controller bodies. We routinely do what we call POCs. They're proof of concept builds. So essentially, prior to going into production, the engineering teams will get off tool parts from the factory. And then what they'll do is they'll sit down and assemble all those parts together. Well, so let's say like an Xbox controller, and they'll sit down and assemble all of these parts together to understand where the fit and finish is, where they may run into issues in production. But routinely what happens is the POC build is going to happen on the 4th. Well, they aren't going to receive case parts until the 7th, right? And they can't wait until the 7th. They've got all the other parts, but they can't wait until the 7th to kick off this build, or they're going to be behind. So what we'll end up doing is 3D printing those parts in the interim until the real parts arrive, and so they can at least get started to start to understand where the flaws are, or where the production issues may occur. And so Formlabs has been the Formlabs has really filled that niche for us, where we need something that is engineering grade materials. All the other processes we use, like PolyJet, are it's a wonderful technology. I can do multiple colors, that kind of stuff, but it does have its limitations in strength and surface finish. One of the other aspects of especially the Form 4 that we've noticed is the surface finish has really taken a step up. We had initially at one point in time purchased a low-cost resin printer, screen technology printer, literally a consumer grade printer, because of the surface finish we were able to get on it for certain objects, where we could simulate textures on like, say, an Xbox controller, that kind of stuff. And when we received the Form 4 and did our first prints on it, we were amazed at the surfacing that we were getting off it. I mean, it was to the point of where we'd have a texture that had a 0.01 difference between the surface height of a texture, and you could actually see, not only was the parts smooth right off the printer, but you could actually see the difference, a 0.01 difference between two textures, which you can't achieve in PolyJet or SLS or any other technology. So you quickly become an advocate for this technology when you can see the advantages it brings.
Yeah, and as far as like material selection, like the forms kind of started as an internal only, like myself and some of the other people doing some like mechanism development, and people doing the architecture for how the models get made. So material selection kind of relied on us to decide what material would be best. And a lot of it is like, oh, this part would normally be used in ABS, so I'll use Tough 2000. Or just like, as you get to know the material properties, we just begin to know what material would be best for a certain application. And so we began making models with the form, and it wasn't available to our designers, but the designers would be receiving those parts. And so over time, the designers would realize, like, oh, there's this technology, and they'll actually start calling out, like, can you make it out of the same material you did for this one? And so the word of using these materials has kind of spread. And so that's kind of how material selection goes. It's still case by case, but experience, like people handling the parts more and more,
Yeah.
people know what they want more and more.
Within, your guys' own personal printing experience, do you two have a personal favorite material that you like printing in the most, whether it's, for your own print or for internal use?
Um, I'd say my top three would be Rigid 10K, uh, Tough 2000, and Durable.
Yeah,
I think,
on the side, I design board games, and so Tough 2000 has become my go-to resin for figures and game pieces.
Very cool. Yeah, I think those are definitely two of the more popular ones here. There's lots of rigid 10K prints around the office. I think my favorite's probably in between the Tough 2000 rigid 10K, the rigid 4K. I always joke it's sort of the middle child of our materials. where I think a lot of people jump straight from Tough 2000 to Rigid 10K, but I think Rigid 4K is also in a really great spot where it's got that hard white, almost porcelain look and feel to it, but it's not quite as brittle. We spoke earlier, and you guys told me a little bit about the architect role at Microsoft, and I think it's a really interesting role. I think it's one of these unique things that Microsoft does that sort of sets it apart in the industry. Could you guys tell everyone here a little bit more about the architect role, how that came about, and how that fits into the work at APC?
Yeah. So I'm an architect, and so my job is kind of orchestrating how models go together. So we'll get a request, and I'd say about 80% of my work comes from our industrial designers. And so we'll receive 3D models or like CAD from them. Uh, and most of the time it's like render data. And so it's only the exterior surfaces of the model that they want to make. So if it's a laptop, it'll just be like the outer surfaces, the screen, the key set will be there and everything. But there's no like hinges, there's no method intended with the data to assemble. And so my job is to coordinate with like with Mark, with our CNC people, and with our finishing team, who do all the sanding, painting, assembling, and kind of determine how a model should be made, how it should go together, and what level of quality needs to go into it. And so I'll go in. I can touch everything on the inside of the model, but I can't touch any exterior surfaces. Uh, and so I'll go in and make the key set like its own block that we can print and then sand and paint and apply like the letters to and everything. And yeah, it's kind of up to me. Like if we need to machine something, I have to make sure the parts that I'm sending to get made are machinable. And same thing with printing. With PolyJet, it's not too critical to think about how it'll need to get printed, but we do some parts. Like for a while, we were doing little speaker meshes, which I think I sent you guys a photo of. But we did the little speaker meshes just to add a little bit more detail to our models, as well as like the tangs that are on the inside of like the USB ports, are like surf link connectors. Yeah. Yeah, so I think lower on that. Yeah, those guys. So the Formlabs really kind of helped us get like the small detail parts that would take too long to machine to get any meaningful value out of, but we're also too small for like printing in PolyJet. And that's kind of where Formlabs fit in pretty well. But yeah, my job is to kind of just orchestrate how a model goes together, make sure the parts are producible by us, as well as developing any like mechanisms or hinges that need to go into it.
Very cool. That's an interesting role as well, because there's, you got a team that decides how something's going to look, and that might be, the ID team, and then you have the team that sort of decides and makes it work the way you want. And you're kind of in between the two, making sure that it looks the way one team wants and works the way the other team wants, but that both of those things come together. And I think
Right.
sometimes that doesn't happen at different companies. One team will win out over the other, but I think it's pretty cool that you're in between, making sure that it comes out working and looking the way you want, sort of the mix of form and function.
Right.
Yeah. You shared some photos over with us of some different applications that you guys have used Formlabs technology for internally. We can throw those up on the screen and go into a couple of the ones that are your favorites and what that looks like from how it came across and what the process was like. Um, Also, before we get into that, I see that a lot of the attendees have already found the Q&A. Thank you, everyone, for joining. If you haven't found it yet, there's a button right along the bottom for Q&A. We'll save some time at the end to try and get through as many of those as possible. You can post your questions in there at any time. So if you've got 1, 2, 3 questions in your head, you don't need to hold on to it until we get to that section. Put it into the Q&A at any point. If you see a question you really want to hear, you can give it a thumbs up so that it pops up in our queue. So if you have anything you want to ask, toss it in there. But with that being said, out of the few different applications that we've discussed, Ryan, do you have a favorite application or two where you've used Formlabs technology that sort of your favorite use cases?
I'd say more of the rigid 10K, using that for stamping sheet metal parts is pretty exciting, as well as using it for injection molds has been a lot of fun. Yeah, there might be some images lower down in that album. Yeah, so we have a few guys in the shop who do a lot of like press tools for like internal components and stuff.
Mhm.
Yeah, I think that was like a shield for some sort of electrical component. Um, but being able to print molds instead of like uh, previously we'd machine them out of aluminum in order to get uh, that type of part. And so being able to print them without taking up like CNC bandwidth has been really awesome. And then we also have dabbled in injection molding. We had a small like hand operated injection molder for a little while that we were messing with. We've since gotten a slightly like bigger, medium, like desktop sized machine, which I haven't messed with too much. But if you scroll up a little bit, uh, I did do some messing around. Yeah, there's the 3 in the middle left. I was trying to make new lock cylinders for my car, and so uh, it was a lot of fun, like designing the molds and just doing one-off parts with the rigid 10K was pretty exciting.
Yeah, one of the great perks about working where we work is we have access to a lot of toys to play with for making stuff, and very much encouraged to work on projects that will inform or work on personal projects that will inform processes for projects that we will do for requesters and for hardware development. So it's like Ryan here spent a lot of time uh, uh, proving out an injection molding process for essentially reproducing a MIM style process where we're injection molding metal filament, liquefied metal filament into a mold, and then sintering it, and then taking that process and utilizing it for internal parts on an Xbox controller that like the thumbstick has a metal part underneath the rubber grip, and he made multiple iterations of that for the hardware team during the development of last controller.
Very cool. This is a very intricate looking piece. Yeah.
Yeah. I think it was
Amazing.
probably half a year to a year of kind of messing around after work, developing that. um, yeah, it's been one of the more fun parts is just having access to the tools and being able to work on your own stuff. And uh, I think the culture in the shop is like the more you learn, the more you can apply that to uh, projects at work, and just the more innovative you can become by doing so. Uh, and so that's one of my favorite parts about working in the shop.
Very cool. Yeah,
Yeah,
it's
Microsoft. Oh,
go ahead.
I was going to say Microsoft has, or at least the Advanced Prototyping Center has, in our architects, a very unique set of individuals who live between our engineers and our designers. Typically these are two teams that do not like, it, working as an industrial designer for many years, these two teams are not usually the greatest at communicating between each other. And that's the advantage our architect team brings. The designer goes, I have this crazy idea. I need this thing to do, this action, right? And that goes to the architect team to figure out, okay, so how do we create that experience? And then once that experience is created to the satisfaction of designers, then we can hand that over to the engineers to turn that into a producible product. But the great thing is that the architects also speak the engineering language. And so you have this bridge between these two groups that wouldn't, normally have trouble communicating their ideas to each other. And the architect is that bridge that creates that communication.
I
A
think
lot of
that's
times we'll make
be valuable too. I mean, you guys have a reputation for making parts that work great, but also look amazing. And I think, a lot of that probably comes down to the work that you do and the other architects do of making sure that um, these two teams can do what they do really well at the same time.
a lot of times we'll make two models for an item, where the one model is the ID intent and the other model is the what ME thinks is realistic. And whether it's like the thickness of a device or something, like ID will submit their own, like, we want it to look like this and be this thin, and then ME will be like, no, you can't, but here's what we're proposing. And so we'll orchestrate two models to show the two side by side, and it's up to, we'll give those to the ID and ME guys, and they'll kind of battle it out to find some sort of compromise, hopefully.
Um, you kind of touched on it a second ago, Mark, as well. The uh, ability for people to work on personal projects. It's not just something that you're allowed, but it's actually encouraged to help build those skills and sort of advance the capabilities of the entire organization. Um, we're almost at a time. We'll get to questions in a second, but before we wrap up, I'd love to know a little bit more about the ability to work on these personal projects, the space for it. And if you guys have a personal project that you're working on or have worked on in the past that you want to share, I'd love to know more and share that with everyone here today.
Cool. Yeah. One of the best things about working here is that every tool is open to every person. Just because I'm the 3D printing lead doesn't mean I couldn't go learn CNC if I wanted to. That the ability to learn any process within what we do in the APC is literally open to everybody. It's basically uh, uh, based on what your interests are. I use it for, like I said before, I design board games on the side. So I use it for pieces. We are currently running we have every October we have this thing called the Give campaign, where it's all about charity and donating to your charity of choice. We have a group that runs a 24-hour D&D campaign, and for them, we printed figures. Typically, they've gone through Hero Forge to print out their figures, but this year there was like an 8-week time delay, so they came to us. We got to print out those figures, and so we did stuff like this where we printed little figures for them. And then the great thing about the Form 4 is we went, well, if I can do it, if I can do the figure this big, well, why can't I do it this big? So in the end, what we did was supply them with their little figures for the game, and then we're also going to be giving this one away as an extra bonus. So and that all comes down to the ability of the Form 4 being able to produce parts very, very quickly.
Very cool. How about you, Ryan? Do you have a personal project or a project that you've worked
Yeah.
on or are currently working on that you'd call your favorite?
Yeah, so I have a Datsun 280Z, and so the majority of my side projects are related to that. And I'd say my favorite one is in the photos that you guys have, is a rear view mirror, a fender mounted rear view mirror. And that was like a year and a half long project for me. Just replicating a super rare fender mirror from Japan that I modeled off of some pictures I found online. And so we have a metal 3D printer, the Mark Forged Metal X. And so I printed the stocks for that mirror in stainless and polished them. The clear part is printed on the Form 3, I believe, and sanded, clear coated that, and then made a mold to cast into a slightly stronger material. And then if you scroll down a little bit, there's the knurled ring that goes on that, and that was printed in rigid 10K. And I just painted that silver, and those have been on the car for, I think, 2.5 years now. Yeah, and just all the test prints and stuff were with the Form 4. You can see the base plate for making the rubber mold. I also printed in gray on the Form 3. Yeah, and just like you can also see my headlight bucket. I had to make a custom mount, and so that was rigid 10K too, and those have also been on the car for a year or two now. So yeah, just anything that I can reproduce obsolescent parts for my car has been my favorite thing.
Very cool. And it sounds like they're holding up well, which is always great to hear.
Yeah, yeah.
Yeah.
I was afraid that knurled ring, like any sort of like rock or something, would like kind of shatter it, and I would lose the clear part because that's the thing holding the mirror together essentially.
Hmm.
But this past spring, I did a road trip with my dad, the Overcrest Rally down to Utah, and so we did like almost 3,000 miles with those mirrors on the car through the desert and everything, and they're still perfect.
Yeah, I think the just average environment that something on the exterior of a vehicle has to go through. You definitely need to have something that's well designed and also well made. Just between it's exposed to water and sun and heat and cold and impact, sort of everything that you can imagine is thrown at those parts. So really cool to see it, being used. For automotive applications like this.
Yeah, definitely.
Actually, that's a fantastic segue into questions. We've got about 10 minutes left, and one of the questions here was on using clear resin for making parts on the Formlab printer, and if you have any tips for achieving good clarity. So this is something that, you know, it's sort of all over our social media page, doing things like printing glass bottles or cups that you can't tell apart from a real glass one. But you know, the part that you had on your vehicle there looked amazing. How exactly did you get it from, you know, fresh off the printer to installed on the vehicle to make it that clear?
So that part I did a lot of sanding on. Um, I think I went up to like 800 or 1,000 grit uh, on that part in particular. And then we have like automotive grade clear coat in the shop. And so before casting it, I sprayed it with clear coat
Hmm.
and did a little bit of polishing afterwards, just to make sure that it was perfect. So sanding and any sort of clear coat will get you pretty far with that, I'd say. I did do a couple tests. I was making an RC car, and I 3D scanned my taillights and printed little 1/24th versions of them, or 1/10th versions of them. And those I just straight clear coated, and with uh, the Form 4 having such a good finish, like even just clear coating them without any sanding, they came out pretty good. So I'd say clear coat at a minimum, sand and clear coat if you want something like crystal clear.
Yeah, that was one of the biggest advantages of having SLA technology in-house was printing polyjet parts in clear. There's very limited use cases for them because of the way the layer process works in that technology. And while it has many advantages, it also the Formlabs clear, especially once we stepped up to the clear in the 4, the clarity in the parts is enormous. It's as close to optically clear, cast optically clear as you're going to get in a 3D printed process. We're constantly amazed at the end result that we can get off the Form 4.
Well, glad to hear that the experience is still going well. Also, we're going to toss an exit poll up as we get through as many questions as we can over the next 10 minutes or so. So it should be popping up on your screen. If everyone could click through those, that'd be awesome. And in the meantime, we'll keep going through the questions. So we've got one here that I think is for either of you two, or perhaps even both of you would be great. From Frank. He wants to know, other than speed, what else stood out for you with the Form 4? You know, obviously it's significantly faster than the previous generation, but on top of that, what would you say was the one other thing that you noticed that had a bit of a wow factor?
Yeah, for
Um,
me, it was two things. Every system we've ever had from Formlabs, ease of use has always been. It seems to be very much in the DNA of how Formlabs designs their products. From the fact that everything that is user accessible is lined in blue. So when you walk up to the machine, you know if something's labeled in blue, that's something that the end user is supposed to use. That just makes the end-to-end use from start to finish as push button as possible. I've also seen a significant improvement in auto supporting. Um, you know, um, I am the subject matter expert here at Microsoft for 3D printing, and I decided I was going to buy a 3D printer at home. And so, I bought a very low cost 3D printer, resin printer at home to play with. And I quickly came to the realization that I was very used to very baked software, software that was push button versus something you can tinker with. There's everybody who uses 3D printing, runs the gamut from I really want to get under the hood and understand every small aspect of how a 3D printer works, to the person who just really literally wants to put a model into the printer and get a part out. And I'm tending a little on the side of I just want to get a part out. I don't want to have to worry about what the pull force is, or what the cure time between each layer is. And the great thing about Formlabs is it knows how to kind of ride that line on making it as easy to use for the person who all they want to do is grab a model, stick it in the machine, hit the button, and get a part out, to the people who maybe want to get in under the hood, with some of the features of the open resin model that you guys have. So yeah, that's what I like.
There you go. How about you, Ryan?
I'd agree with like the usability and just the interface of like reloading trays and uh, all that it's just a great experience. And I'd say the resin cartridges feel a little more refined, as well as just like the resin filling is a lot faster. Uploading models is a lot faster. Yeah, just overall, I'd say just everything everything has been very very good on that.
Very cool. We've got time for one more. There's also some questions that are sort of just quick, easy ones. So if you put something in on, what material fits, most similar to this, I'll type those as we go. But one more that we could do live. Victor's asked a question about the workflow. Sort of with the Form 3 and with previous technology. It sounded like your guys' workflow is to launch your prints in the evening and then have everything ready the following morning. How do you guys sort of manage it all internally with the Form 4, with other technology of these prints coming in, being printed and going out? What does that look like from your side of things?
Excuse me. For us, for me on my side of it, so I have a team of 3. One person whose concentration is SLA, and so as we've grown our use of SLA, that has allowed us to open up same day and sometimes same hour delivery, depending upon the material and the size of the part. And we are quickly moving towards expanding the use of Formlabs in the way that we can deliver parts as if I was an architect who I just have an idea and I need to print a part as quickly as possible. I'm able to work outside our general system, or at least have my tech work outside that system, so that we can move parts much faster, allowing our engineers to make decisions quicker and do multiple iterations, sometimes within the same afternoon.
Yeah, for a while when we first got the Form 3s, we had a big like group chat of like Formlabs users, or like self-serve 3D print users. And it was up to everyone to kind of just coordinate, like, hey, I have a rigid 10K build I want to do tonight. And if anyone else had more parts to add to that, if there was space, then we'd kind of coordinate, and at the end of the day, kick off a print. And with the Form 4, I'm seeing like there's not as much communication as far as that goes, because we can kind of kick off a print in the morning, and then the printer's free by like midday for someone else to use. And so yeah, it's just kind of yeah, it's all self-serve right now, and if with the Form 4s being faster, we're able to kick parts off to Mark's team as well, and get things much quicker.
Very cool. Unfortunately, we're out of time. While you guys are answering these questions, I'm also typing through some. But I appreciate everyone being so engaged that the new questions are popping up almost as fast as we're getting through them. So I want to thank you guys for taking the time and running this webinar with us today. I know I learned a ton and had a great time, and I hope the attendees did as well. Attendees, thank you guys for joining. I know everyone is really busy, and the fact that you guys are willing to take an hour out of your day to join us and learn a little bit about Formlabs and how Microsoft is using these printers to continuously innovate is something that we definitely appreciate. So thank you everyone for joining. Mark, Ryan, thank you guys so much for your time. We'll be sending this out as a recording, so anybody that wants to review it or anything like that, we'll be sending that out. But thank you everyone. I hope everyone has a great day.
Thank you.
Thanks.
Bye guys.